Okay, so we are now live. This is SIG Network Policy Evolution Subproject. Today is December 21st, 2020. I kindly remember you that this is a cloud native Kubernetes community meeting. So we have running here the code of conduct. So please be nice with each other. And the agenda of today is dedicated to folks that have been working with the cluster scope and network policy to present to the rest of the sub project to this meeting what they have been through. So Abhishek, Yan, this is with both of you.
All right, thank you, Ricardo. Thank you, everyone. First of all, can you guys hear me well and see the slide deck?
Yeah, actually we see both of them, the slide deck and the presentation, the next slide.
Oh, okay. Let me fix that. Is this better?
Yeah.
Yeah.
Okay, great. So, yes, well, first of all, thank you for giving this opportunity to talk about the cluster scope policies. As you all know that, we have been collecting user stories across everyone for network policy evolution. And some of those user stories are kind of aligned for administrators and kind of demand a new resource. So a few members within the network policy API team started exploring how to solve that problem. And so I want to first of all thank a lot of other people who have also contributed to not just the proposal but also to the slide deck. Gobind Johar, Yang Ding, Christopher Luciano, Vinay Benai, Satish Mati, and Zhang Li, who initially also did help us in the proposal. So a big thanks to all of them. The agenda today is that we're going to look at, first of all, why we need the cluster scope network policies, and then some of the use cases that demand this resource, and then we're going to discuss through the proposal. Also, then we'll do a little bit of deep dive with some of the proposed fields which needs more attention, and eventually we'll go through some sample examples, and finally some to-do actions, and get feedback from everyone. So hopefully this will be a more of a back and forth between us and you're all asking us questions and discussion. So feel free to interrupt at any time. And I do expect that this may go or span, this presentation spans over multiple sessions. So feel free to stop us and ask questions. And I think most of the other team members are, because of holiday season, they are not here. So it's just going to be represented by Yang and me. So Yang, feel free to stop by and
No,
comment
Abhishek, Vinay and Satish are
I
also
see.
here. Yeah,
All
I
right.
just joined. Yeah.
Great. All right. So Vinay and Satish are also here. So thank you. So feel free to interject and correct us and or respond to questions. All right. So let's first take a look at uh, the reason why we need cluster scope network policy. Uh, Essentially, what happens is that we have multiple personas today that exist in a Kubernetes environment. The developers who are responsible to define services and their workloads, and are kind of namespace code, perhaps sometimes overlapping namespaces as well. And then there's another persona which is that of a administrator who's responsible for the maintenance of the cluster and has in general higher privileges and authority than a developer. And sometimes a cluster administrator needs certain strong guarantees about the behavior of its network. And so what happens is that today in Kubernetes, we have a network policy resource, which is mainly developer focused APIs. So generally what we have been seeing is that whenever some administrator oriented feature ask is made, we kind of push back saying that the network policy is meant for the developers. So the evolution of network policy, maybe takes a while, and perhaps some of those use cases are not addressed. So that's one of the reasons why we need a new resource, which is complementary to the network policy resource. The cluster administrators also want to sometimes deploy these policies for the entire cluster, as opposed to just the namespaces, or maybe copying it all over the different namespaces that are available. And they also don't want a developer to intentionally or unintentionally override certain security guarantees that a cluster administrator may want to have. So, an RBAC also doesn't really help that much, because RBAC tries to solve a different kind of a problem, as opposed to what network policies or security policies intentions are. So, so that kind of leads us to the need for a different resource, which is on a cluster scope and specifically tailored for administrators. Some of the use cases that we collected, and these are not limited to these, but just something to highlight. What we've collected over months of this activity that this group has done. When I say this group, I mean the network policy API++ meetings that we've been doing since the beginning of 2020. I think a lot of people want to have the ability to so let me back up. Administrators sometimes or Kubernetes clusters sometimes are multi-tenants. So you want to allocate certain namespaces to tenant A and certain other namespaces to tenant B, and so on and so forth. Then in that case, having a security guardrail, or as a security aspect, that these namespaces should not overlap, or these traffic from namespace for tenant A should not cross into traffic destined for namespace or tenant B. So there is a need for some sort of an intra namespace allow and denying the inter namespace traffic. It can be achieved with Kubernetes cluster network, with Kubernetes network policies. It's just that it needs to be repeated in every namespace. And on top of that, the developers or the tenants have the ability to override these network policies by adding a namespace selector in there to from, and then you kind of do not guarantee these things. In certain cases, for every Kubernetes cluster, an administrator may want to allow certain traffic by default or as a baseline. Most pods that come up, or most services that come up, they would want to talk to the kubedns or core DNS pods that exist in your Kubernetes cluster, and they probably reside in one namespace and not probably spread across every namespaces. So these kind of baseline rules needs to be enforced, to just guarantee that certain connectivity is available. In certain cases, you want to restrict certain siders, which probably the workload should not talk to, and perhaps in certain cases they want certain siders to be accessible. So again, this can be done with Kubernetes network policies. It's just that with as a cluster administrator, you can give that guarantee to every namespace that comes up dynamically, instead of having to do some sort of a additional tooling on top of your cluster. We have also seen certain use cases where you need to manipulate the traffic in your Kubernetes cluster in a way that you only want to allow traffic ingressing or egressing certain namespaces through some firewall gateways or security gateways that exist in your Kubernetes, in your cluster. Now, the intention here is not to do manipulation of that traffic, because that is kind of outside the scope of a network policy. Uh, the intention here is that a cluster admin should have the primitives or should have the ability to express these kind of traffic enforcement. So if there exists a security gateway or a way to manipulate traffic, there should exist some ways in the network policy APIs or the security APIs to allow that sort of manipulation. And we also may want to, certain clusters may, let's say, have, fall under an attack, or you want to deny certain pods or certain services being accessed by outside IPs, which are trying to do a denial of service on those services. So temporarily, you may want to enforce a rule that denies this particular traffic, so that you can reevaluate your cluster and take necessary precautions. So you need a way to explicitly deny certain traffic, either egressing or ingressing to your services or your pods. So these are some of the use cases that we collected over time. And if you guys have any question, feel free to unmute yourself and ask. I will move forward. Now, having those use cases in mind and the motivation for a new resource, when we started out writing the spec for a cluster scope policy, these were certain guiding principles that we kind of tried to adhere to. And those were the design goals that we wanted to achieve at the end of this proposal. So our guiding principle was that we need to focus on the needs of a cluster administrator and not the app developer. That doesn't mean that the app developer's requests or features that are necessary for a developer are ignored. This particular group, the network policy subgroup, does look at all those use cases, and anything that is developer focused, we can try to evolve the existing Kubernetes network policy resource for those use cases. But for the cluster scope policies, we are going to focus on the needs of an administrator. We also want to ensure that we follow the network policy API as much as possible to give a familiar experience to users. Anyone who's used network policy APIs or written policies should not have a tough time writing cluster scope policies. The transitions should be smooth, and of course, as an administrator focused policies, the cluster scope policy is going to be slightly more complex than the Kubernetes network policy, but our idea was to keep it as closely matched to the network policy API so that the learning curve is not much. We also wanted to limit the amount of complexity that the API can, because as the administrator focused use cases can get complex, a lot more requirements can come through for this particular resource. It can get complex quite early. So we wanted to simplify some of that. So there were multiple proposals that we could have gone forward with, and of course they also remain as alternate proposals because as part of the coming up with a proposal for cluster scope policy, we looked at prior art which exists today. For example, some of the network providers already have CRDs for cluster scope policies. For example, mainly I think Calico, Cilium, and Antria has a global or cluster scope policies that is available. So there is some prior art. So we looked at all the three specs, and one of the things that we tried to avoid was the ability to assign priorities to policies, because It may make writing policies a little bit more tedious, because you now need to remember or rely on the ordering of policies. So we try to keep it a little simpler, and not make that complex. But of course, if we deem that our current proposal does not satisfy all the use cases, or if we think that the ordering based or priority based proposal makes more sense and is more a more perfect for this, a perfect fit for this particular resource, we can always go back to the drawing board and work up a solution based on that. But hopefully we can find that this proposal solves all use cases, and we can move forward in this fashion. We also wanted to ensure that the APIs that we introduce is expandable in future. We want to make sure that if there are new fields to be added to a cluster scope policy, it should not be difficult, or it should not really warrant a V2 or a V3. Perhaps it should be additive to the existing proposal. So those are some of the principles that we wanted to stick to, and hopefully we can, as we grow this proposal, we are able to stick to those principles. So based on that,
one question on the principles. Are we going into the kind of like designing the API? Are we going to have a stance on how lenient or how aggressive we're going to be around compatibility? So like, is the first iteration going to be? Well, I guess like we have to start alpha, but like, are we going to create the API as alpha, knowing that we're going to probably break something, or are we going to be alpha but still be pretty conservative around breaking users going into beta?
So I think the idea would be that before we go to beta, we have a good amount of use cases satisfied. I'll talk about some goals and non-goals, and I think that will be a good point to talk about, like how the versioning might be able to be. We can do that. But the idea is that once we go GA, it might, it will just be quite similar to how Kubernetes network policies are. Once we want to add, let's say, the namespace by name, we had that issue where that if we are introducing a new field, it changes the semantics. So we will try to conserve as much as possible, but there are no guarantees that future use cases that may come up, we might be able to solve today itself. But at least I feel that we should have like maybe a couple of iterations of alpha v1, alpha v2 before we go into beta, and hopefully the beta is more stable.
Right, Abhishek, this is Vinay. Just to add to your point, right? I think you make a very valid point. I think just out of curiosity, I think our definition of a alpha API means we hopefully try not to break it too much, but at least that allows us to break, right? I think once we go into beta, I think is when we want to keep the API more stable. That's my understanding at least. So feel free to chime in, like if that is not the understanding of everyone else.
Yeah, I think that's the general understanding, or at least it's the rule. But like we can still make statements, or still try to say, like, people have built alpha APIs, but they treat them like beta APIs because they know that they want early adopters and they don't want to break those adopters. So just kind of staying from the start, like, this is an alpha API, we're going to break it, versus this is an alpha API, please use the alpha API, and we're going to try our best not to break it. Like, I think it's good to set that.
Yeah, and I think I agree with what Abhishek was saying. I think we should use at least the first couple of iterations of V1 to the alpha version to see, what feedback we're getting in the field, and then based on that, if we decide not to break it, great. If we decide to break it, unfortunately, we will have to. Okay, so we are on agreement.
Yeah, that makes sense.
Yeah. To add that point, I feel like it would be a good thing if we can sort of like get some big CNI providers to be on board with this plan when we are trying to do alpha for this. So if we have sort of some sort of like consensus on this should solve a lot of use cases, and the CNI providers are generally think it's implementable and the specs and everything makes sense, then I think we should be in a pretty good shape when we do alpha. That's my opinion on this.
Yeah, I agree with what Yang said. I think definitely need the support of CNI providers, because at the end of the day, a network policy related resource like cluster scope policy without any implementation is probably not going to be used at all. So it is definitely very important for us to have at least the top CNI providers back this proposal. So hopefully once we move this proposal to the SIG network, and once we are ready to publish the alpha APIs, we have enough backing from the providers. And that's probably something that maybe we can take up during the SIG network meeting. Okay, so if there are no more questions, I will move forward. So yeah, so those are the guiding principles. We also, so as part of that, we kind of ended up with certain design goals for this particular proposal, which is, I think we need a explicit deny rules, which is unlike in the Kubernetes network policy, we don't have such action. They're all whitelist rules. So we do need a new action for deny. We want to provide baseline security. The cluster administrator should be able to define some sort of a defaulting rules or baseline rules for its cluster. At least some guarantees for the Kubernetes cluster, but they can be overridden by the developers. So we should leave the baseline rules can be overwritten by developers using Kubernetes network policy. A very good example of this is the namespace isolation, where as a baseline, whenever a new namespace comes in, the intra namespace traffic is allowed and the inter namespace traffic is denied, and that's a guarantee that we give. And perhaps there is a tenant who owns more than one namespace, and he or she may want to open up traffic between their namespaces. So they should be allowed to do that. So that's one of the goals. The other goal is that a cluster administrator perhaps does not want the developers to override some of those rules. So in this case, the admin wants strict enforcement of those security policies, and Kubernetes network policies should not be able to override those rules. So those, they seem very conflicting goals, but I think we can demonstrate that we shall be able to overcome, or we should be able to address both of these use cases. The other goal is that the administrator should be able to select pods on the entire cluster. So essentially, this goes back to the scope of the policy resource, which is on a cluster level as opposed to the namespace level. And finally, we also want to ensure that there's compatibility with existing Kubernetes network policy. What we mean by this statement is that we do not intend to change any inherent qualities of Kubernetes network policy. We don't plan to override its behavior, or rather, we don't plan to change its behavior or the expectation. Of course, when you have security policies defined at multiple layers, like at a cluster policy and a network policy, the overall effect on the cluster will be different. But that doesn't mean that we are changing the meaning of writing certain Kubernetes network policies. So the idea is that both cluster scope policy and Kubernetes network policy coexist. They are complement to each other, and the usage is one is for the administrators, the other is for developers. So those were some of the goals that we thought that we should achieve, at least as part of this first proposal. Some of the non-goals also worth mentioning. Now, when I say non-goals, I don't really mean, or we don't really mean that these goals are not for the cluster scope policy. These are something that can be addressed as part of the first iteration. It's just that it's not the goal of today's proposal, because in our initial proposal, what we wanted to tackle was we wanted to tackle the precedence and the complementary behavior between network policy and cluster scope policies. We wanted to tackle the goals that we just previously mentioned. But there are other use cases like, for example, the node policies. That's something that is also applicable for the cluster scope policies. But it can be debated that it can also be applicable to Kubernetes network policy. So the idea is that we can have separate discussions for such use cases and see whether they can be solved for both the resources. And if yes, then we inherit it from that proposal. If not, then we'll certainly try to tackle it as part of the the original proposal here before we go alpha or even beta, so that we are resolving majority of use cases that lie out there. So, but at least for today's session, we don't plan to introduce these use cases, which is logging. I know it is some of the use case, some of the requests that were made on Kubernetes issues were around audit logging for traffic that occurs in a cluster. It's a useful feature. Perhaps we can follow up on this. Error reporting is something also that is quite asked because sometimes users do not understand whether a policy was realized successfully or not. And I think the same this point is valid for both the Kubernetes network policy and the cluster scope policy. So I believe Dan Winship has kept some around this for the network policy resource as a part of a status sub resource. And if that's something that is moving forward, then I think we can also implement the same for the cluster scope policy using a status sub resource. But at least we won't discuss that today. The node policies, this is something that comes up often. We want to. There are two things. One is we want to apply policies on nodes, and the other is we want to have the ability to dictate traffic between pods and nodes. So on one hand, the applying policy is on nodes. On the other hand, the applying policy is on pods as workloads. So again, that's a non-goal for today's discussion, but it is something that is also interesting for a cluster scope policy. We will also not talk about new selectors, for example, service selector or service account selector or DNS policy, because already I think in some members from this group are exploring these policy targets separately. So maybe we can keep those discussions in those threads. And then we can again inherit them. And again, in the end, we don't want to solve a cluster network policy for every possible permutation. I think what we want to convey here is that there are multiple ways to do cluster scope policies. For example, you can also do hierarchical policies, like tiered way of policy enforcement. That's not the goal here today. It is certainly something that might be useful because some network providers already do implement and provide that solution. But if it is necessary, then maybe we can take a look. But at least in today's proposal, it's not part of the scope. It's not in the scope. Any deal breaker here, or this sounds good?
I wanted to touch on one thing in the last slide. Mm-hmm. I think the non-goals are pretty good. For the goals, I think trying to keep parallels with the current network policy API is actually is a really good starting point. But I do think that, like, if we get to a point where there is a much better way to express an API that would not be kind of similar to network policy, I don't think it should be kind of off the table because it's too different from network policy API. Like, I think we should explore kind of things that may look different if it's a much better way of expressing intent. So just wanted.
So Andrew, that's a good point. I think, like, this is, like, by the way, Vinay again from Google. So one of the things that we felt it may be more useful with both the deny and allow context, it gets, like, very complicated, right? So having and people are used to using a certain semantic, like in terms of selectors and ingress and egress. So if you use the same language or the grammar, I think it will be a lot easier for people to comprehend, because with the cluster network policy, for better or worse, it has gotten a little bit more complex in terms of like, with the prioritization of the cluster network policy or network policy and default allow or the baseline allow. So all these things get, so this would be useful. So now what you're suggesting, if I heard you correctly, you're saying if we feel that there is a better way of representing cluster network policy, and if it breaks with the way we have network policy defined, the API, let's go for it. Am I reading you correctly?
I'm just saying like I think we should always start with what's familiar. Like I think that makes sense.
Yeah.
I guess all I'm saying is like we shouldn't put something off the table because it's too different from existing APIs. Like all I'm saying is like, we should consider different ways of expressing things, even if they seem different at first.
Yeah.
But I definitely agree with starting and leaning towards APIs that are, familiar to users and already existing, for sure.
Yeah.
I think that probably the point here is also that we have like here the opportunity to change what we think that's bad into the old API, right? So we can use this moment to like implementing the cluster scoped network policy that, oh, we are not going to deal with priorities because we don't have them in Kubernetes network policy. And I also think that we shouldn't like remove this from the table just because that's not compliant with the Kubernetes network policy.
Yeah, I agree. I think it's a good time. There's a lot of confusing parts, like for people just hopping in and network policy. I think there's ways we can improve it, and this could kind of be a roadmap to do that. So we definitely shouldn't restrict ourselves just because it's already defined one way.
So hey, Abhishek, I had like one more point I wanted to make. So if I heard what Ricardo said and what Andre said, so I just want to get a clarification. Are we saying that coming up with a breaking change for a network policy, a new version of the network policy, which takes into account the prioritization, deny, allow, the cluster level and at the network level, is that something we should put on the table?
I don't think we should break how the network policy works, but I think that we don't need to stick with the like follow the network policy API as much as possible for a familiar experience. I don't think we should remove anything from the table because that's not like the experience from the network policy API. I guess that like if the decision of breaking something like backwards compatibility from cluster scoped network policy with the Kubernetes network policies from the CNIs, because here we are just proposing the API itself, right? We are just proposing the object. We are not proposing how they are going to work with that. So who is going to decide what's the backward compatibility between them? It's the CNI providers. But I think that yeah, Andrew will say that breaking is the wrong word here because we are saying about new research. So because this is a new research, that's the same approach from the Ingress object. When they decided to draw the new Ingress, the Ingress v2 that they call it, and later they call it as a service API, they saw that the previous experience from the Ingress object wasn't what they were looking for into the proposal for the service API. So I think that what Andrew is saying here and what I agree with that, it's that we don't need to stick with the follow the network policy API as much as possible, because we have like here the opportunity to change how it works and figure out what the cluster admin they expect from the network policy and add as much as feature as possible without sticking with the old network policy. And maybe later we can like discuss if network policy API also needs some sort of syntax evolution as the network policy API, as the cluster scoped policy.
Yeah, but I do think that like what Abhishek already mentioned is like a good starting point. So I don't think we need to change anything right now. I'm just saying, like before we go to beta, if we find that there's a way to collapse like 10 fields into one field, and like we want to do that, like we shouldn't not do that, because if the only reason is like this is too different from network policy, we're not going to do it. I don't think we shouldn't put it off the table just because of that reason. But as a starting point, this seems fine. So ignore what I said, pretty much.
Oh, no, I think it's pretty, I think we should probably word it differently in the sense that it's nice to have this design goal. But of course, if like I think in previously when I mentioned that when we looked at prior art like Calico, Andrea, and Cilium for their policies, they are slightly different than the Kubernetes network policy because they have the ordering effect and priority based. So, but if we do feel that that's the right way of expressing these intents, then I think we should go for it. It's just that if that's a broad agreement in the community for that, but I think to as a starting point, I think it makes more sense to start something simple and which is more familiar. But I think one thing that we should definitely not try to do is that we should not break the Kubernetes network policies meaning today. For example, the cluster network policy is not being written to replace the Kubernetes network policy. It's meant to be a complementary to it. So at least that we should maintain that. So I hope I was able to correctly summarize the discussion here.
No, I think you're right, Abhishek. Well, I think this is what we discussed too, right? Like I think for the cluster network policy, we'll keep it as a separate resource because I think sufficiently it's the elements of the cluster network policy are sufficiently different that it begs its own CRD compared to merging it with the network policy without creating an entirely new.
Yeah. And I think Andrew Stoichkos brought up that point that certain things are confusing in the Kubernetes network policy, and we have tried not to reuse that. For example, the Kubernetes network policy has policy types as a field. We are not going to reuse the same field in the cluster scope policy because that field was introduced for historical reasons because egress came after ingress. We are not going to do that because we can derive the same thing using the ingress rules or egress rules that are being defined. So we are trying to in our proposal, you will see that shortly that we have tried to not use some of those confusing factors, but also try to have a similar experience. So it's not like we are adding new selectors or anything. We're still working with the pod selector or namespace selector, which are label selectors. So though that's the familiarity I'm talking about.
Yeah, it makes sense.
All right. Okay, so I think we went over this and then some of the non-goals. So before, so without further ado, I mean, we can move into the proposal aspect. So first, I wanted to talk about, more on the technically side, like how the API types looks like. I think probably this is a good way to understand some of the fields, and then we will look at like a sample YAML resource for a cluster network policy with all the fields that we propose. And then I will hand it over to Yang to talk about a couple of specific fields that are new here and which has a certain different meaning because they're cluster scoped and the way we want to solve the problems. So he'll walk you through examples and diagrams and sample YAMLs so that that it's much more clearer. So I'll just first start with the proposal. So as we said, that we plan to introduce a new resource in Kubernetes network policy, in networking APIs, which is a cluster network policy. And before I go through the rest of the fields, I just want to kind of lay it out there that naming is one of the most hardest thing to achieve, and we are not stuck with any of these field names or the value names. It's something that we appreciate more feedback on. So feel free to drop in suggestions for certain fields, which if you think that this name does not convey the meaning of that field. So we are flexible on those terms. So we would love to have more feedback. So having said that, so this is the new cluster network policy resource, similar to the Kubernetes network policy. It has a spec, which is a cluster network policy spec. We could also do a status, if Dan Winship's proposal gets more clarity and people are accepting of that. And we can also do the same thing for a cluster network policy. So a cluster network policy spec, now this is where we will see some of the similarities with Kubernetes network policy that we plan to do something similar, wherein your ingress rules and egress rules can be defined in with the ingress and egress field. So again, similar to Kubernetes network policy. Now, the one difference here that you will see is that if you look at a Kubernetes network policy spec, it has a pod selector here at the spec level. In our case, we decided to rename that field to something like an applied to. What essentially it means is that this policy spec is applied to these set of resources. The reason why we need an applied to here is instead of just a pod selector is because we need to apply policies not just to pods but also namespaces. So for us to make it easier for people to write such policies, we plan to add a new field called applied to, and essentially it will be a pod selector or a namespace selector. Now, if we look at the ingress rule or an egress rule structure, there again you will see a little bit of similarity that you have a ports field. Where we talk about that this particular rule is should be matched against these ports and protocol, and we also get the port range for free because it will be by then implemented in the network policy port. So we should be able to specify a port or port range. And then similar to the Kubernetes network policy, it also has a from section and a to section. From for the ingress rules and to for the egress rules. This essentially tells you that these per set of applied to pods can either talk to these set of pods or can accept traffic from these. So the semantics is pretty similar to the Kubernetes network policy. So no change so far. The new field that you see here is an action, which is of type something called rule action. The action field is pretty important. Is one for one that it is not available in the Kubernetes network policy because all Kubernetes network policy rules are whitelist rules only. But we do want to have the ability to deny certain traffic, so that's why we introduce this new field action. Not only that, the action also determines the precedence of the rule as compared to a Kubernetes network policies. So we'll deep dive into them with examples a little later. But on a high level, there are three types of actions that are available. The rule action allow. Now the allow action is an as-is rule. What I mean by an as-is rule is that it does not have any implicit behavior. For example, let's revisit what a Kubernetes network policy does. When a Kubernetes network policy selects certain pods in pod selector and has certain whitelist rules, if the pod is selected by that pod selector, then the traffic is allowed only by those whitelist rules that are available in ingress and egress. Otherwise, those pods get isolated. So that's the behavior of the existing Kubernetes network policy. On the other hand, an allow rule is as is. That is, there is no implicit default isolation of those pods. The traffic that is matched for this rule will be allowed. And if it doesn't match, then it falls through to the next set of rules. The other thing that then is also worth to note is that an allow action will always precede any Kubernetes network policy rules. So basically, the allow action will be evaluated first. And it is basically, think of it like if you have multiple cluster network policies, each of those cluster network policies may have one or more allow actions. They're all kind of aggregated. And if the traffic does not match any of those allow rules, then it kind of falls to how the traffic is allowed or disallowed based on the Kubernetes network policy rules. So the allow takes precedence over Kubernetes network policy rules. And since you cannot have conflicts between multiple allow rules, they're all additive. They're all since they're just like Kubernetes network policy, they're kind of whitelist. The next action that we see is a deny action. Similar to the allow rule, a deny action is also as is rule. That is, there is no implicit isolation or the opposite of isolation that occurs for a deny rule. So the rule will be evaluated as is. Again, similar to allow, all deny rules, multiple deny rules cannot conflict with each other. So they are also additive, and they, similar to the allow rules, will also precede the Kubernetes network policies. So the deny rules will be evaluated first, and then all the Kubernetes network policy rules, if the traffic did not match any of the deny rules. Now, you may say that there can be a conflict between an allow rule and a deny rule, and that is certainly possible. You may have the same selector, you may have the same port, and you may have the same to and from for multiple rules, and one of the action says allow, the other says deny. Now that's a conflicting rule. Those are conflicting rules. In that case, we say that deny always wins. So now, if we think about the precedence, we have the aggregated deny rules at the top, the aggregated allow rules after that, and then once all of that is evaluated and no traffic is matching, then we go to the Kubernetes network policies, and then we see how the Kubernetes network policies, the semantics remain the same. So that's the current precedence. And then the third action that we introduced is a baseline allow. A baseline allow is evaluated after all the Kubernetes network policies are evaluated. So essentially, this lies at the bottom of the precedence hierarchy. So, and the other difference is, or rather, other similarity with the Kubernetes network policy for a baseline allow rule is that it is similar to a Kubernetes network policy allow rule. In that any applied to, if selected and has a baseline allow in its rule, it will be only allowed if there exists a baseline allow rule. If not, then those workloads get isolated. So this we will look at further examples in the follow-up slides, and I think you'll get more clarity on this. Any questions? I know this is a little bit of a mouthful, so it can get complex, but hopefully the following slides make it more easier to understand.
So Abhishek, I see Andrew was commenting in the chat that you wanted to go from baseline allow to default allow. Maybe you want to give a little quick summary of the discussion that we had in the meetings.
Okay, yeah, so
I know there's only 8 minutes left, so if there's context, I can catch up on it later. I don't want to spend time on the other slides.
Yeah, just a quick response to that is that we started off with the default allow, and I think just last week we changed it to baseline allow, but we can talk about it in the follow-ups.
Okay, yeah.
Yeah, and so this is how the rules are, or rather the API types for the scope resource, cluster scope resource. Now, this is how a sample cluster network policy resource may look like, and it's YAML form. Essentially, this you will see that there is no namespace here. So the name is a sample cluster network policy, and it applies to a namespace selector which is empty, which essentially is similar to how Kubernetes semantics is for the namespace selector. An empty namespace selector selects everything. So here, this will be applied to all the namespaces that come up in the cluster. So as a sample here, you will see we have DMZ, kube system, these few namespaces that exist. The policy applies to all of them. It has 3 egress rules and 1 ingress rule. The first egress rule denies this namespace to talk to everyone except the Istio egress or a kube system. So every namespace can only talk to the Istio egress or the kube system namespace. Otherwise, they do not talk to anyone. it is also allowed to talk to this particular CIDR. So maybe there's an internal CIDR that the cluster needs to be able to talk to. So it explicitly allows traffic to this CIDR for all the namespaces. And it is allowing as a baseline rule, that is, if there is no network policy overriding this, it is allowing these namespaces to talk to the core DNS pods or the core DNS pod that exist in the kube system namespace. So essentially, this is how the egress policies for every namespace is applied. So the UDP 53 is for those core DNS pods. So that's what this particular egress rules dictate. The ingress for these namespaces is only allowing it from DMZ namespace and denies it from every other namespace. So it can only receive traffic from this DMZ namespace. So it's kind of allowing this kind of a workflow here. So this is the sample cluster network policy resource. And I think, like I mentioned, I think this is going to span multiple sessions. Probably this is a good stopping point. I know, I'm sure that there are a lot of questions that may come up, and as we move forward, you'll see a lot of examples that we have here for every these confusing aspects that we proposed. But maybe we can talk about it next time we meet, because I think there's a lot of content left for just 5 minutes. So maybe we stop here, and then if anyone has any question, feedback so far, we spend the next 5 minutes discussing that.
So one quick clarifying question on the last slide there. So there's a deny rule for all namespaces except for STO egress in the system. So if a pod did want to egress out to those namespaces, is it implied that there's an allow rule in the namespace network policy in that namespace? Or does an existence of the, yeah, go ahead.
Sorry, can you ask that question again?
Yeah, so there's a deny rule. The first egress to is a deny for all namespaces except for STO egress and kube system, right? So
correct.
Yeah, so if a pod did want to, if I wanted to allow a pod to egress traffic to those namespaces, is it assumed that I have a namespace network policy that allows it?
No, that's not necessary, because here what it says, like I said, the deny and the allow rules are as is. So it's just saying that we do not have a deny rule for STO egress or a kube system. Now, if you want to deny that, then maybe you need to write a new policy or something, or a Kubernetes network policy to deny that explicitly. If not, then it just waterfalls through, and it will see whether any Kubernetes network policy denies or disallows this kind of a traffic. If not, then it kind of flows through the baseline allow rules. If not, then eventually it allows the traffic. So you don't need to create a Kubernetes network policy to allow that. Is this cluster network policy does not explicitly deny that traffic.
I see. Okay, so if you exclude it from a deny rule, it falls back to the default, which is allowed if not selected by anything else. Okay.
Check. I was just wondering, how would you allow a traffic, deny a traffic only to a specific IP? This is the same, like you put an action, you change that as an action to deny. Is that?
Yeah.
Okay.
So
Okay.
sorry, go ahead. The next.
Yeah.
No,
go ahead, folks.
Yeah. So essentially, for your answer, if you just want to deny, then you would change this to deny. And all deny rules are additive because you won't have those conflicts, and you always have the denies to win out. So you could do that, and you could also do a deny for an IP block CIDR with an except, which essentially would mean that you don't have a deny rule for that except block. It's just that this policy does not create any rules, special rules for that except block. So similar semantics as what we have for Kubernetes network policy.
Thank you.
Also, you could do the same for allow, with the except block.
Okay.
I think Abhishek, I think you may want to point out that it was never the intention that we're going to conclude this proposal in like one session. This is going to be like and a lot of people are out this week, like at least from folks that I know. So maybe I think what we should do is like slides that Abhishek and Yang put together. I think we get an opportunity to go through that, and then in the next meeting, or whenever we have a slot, we go through the. People will have more time to digest it, and then we can have more robust discussion.
Yes, this section is also recorded, so I was like expecting this to get into a YouTube channel and maybe do some marketing about that, so people can take a look into the first look into the proposal.
Yeah, that'd be great. And I think there are a lot of examples we have in the follow-up with like a step-by-step slide on how multiple cluster network policies interact with each other and how the semantics are for the different actions that we have, and also how a pod selector semantics differ in a cluster scope policy versus a Kubernetes network policy. I think those are important fundamentals to understand. And the rest of the slides, I think we have good content to cover those aspects. So I don't know when we will meet next, but perhaps I expect that it will be sometime in Jan. So maybe for the next meeting, we go back through this recording and come back with questions, because I'm sure there's going to be a lot of digesting to be done.
Sure. Sounds great. Thank you. Oh. Congratulations, folks. Congratulations. That's amazing.
Yeah, I just want to say thanks. Great job, Abhishek and Yang.
Yeah, that was great. Thank you.
Okay.
Thanks, guys.
Thanks, everyone.
So for the next week, do you think it's worth us to have this meeting? I've seen some other SIGs canceling the meeting. I'm okay with like how
I don't mind attending, Ricardo, because this is pandemic. We have pretty strict lockdown, so I haven't got any plans. Yeah. So we're all going to be stuck at home, so I might as well join in. But having said that, it doesn't mean others don't have plans. So if you're going to have it, you can count me in.
We can start discussing. I saw your proposal about the service selector, so we can use the next meeting to discuss this.
We can, maybe like okay, that's a good point.
Because I don't think we are going to have like enough people to discuss about the cluster scope network policy, so we can leave those 2 or 3 weeks to people to take a look into the video recordings also and the slide deck and so on. So we can start discussing about that services selector. Sounds good?
All right. See you guys.
Yeah. Okay, thank you, folks.
Yeah.
Abhishek, Yan, all the folks, congratulations. It was great job. Yeah. See you, folks.
Bye-bye.
Happy holidays, everyone.
Happy holidays.
Happy holidays, folks.